Hey 7th graders, today's lesson is 2.3 Evolutionary History. Your learning targets for today: I can model how two different environments can cause differences to shared or homologous structures. So basically today we're going to take a look at kind of the same thing we did in the last lesson, 2.1 and 2.2, and start to look and dig in a little bit more to how environment can cause changes to shared or homologous structures. Okay, yesterday we really started looking at, all right, these organisms have similar structures, but also how are those similar structures different and why are they different? So again, we're going to dig a little bit more into that today. So your first thing you need to do is open up your OneNote and add key concepts 3 and 4 to your key concepts page. Key concept 3 says in populations separated into two different environments, natural selection, oh, that sounds like something from the last unit, causes different changes to happen to each population. This causes descendant species to end up with differences in their shared structures. And again, this has to happen over a lot of years. This doesn't happen overnight. This doesn't happen over a year. This happens over a lot of years, okay? And then key concept 4, when the environment is mostly the same over time, the body structure stays stable. So there's really not a need, as long as those animals are surviving and reproducing, there's not a need for any changes. Therefore, any mutations that we see are going to be non-adaptive. Okay, body structure stays stable. When the environment changes over time, body structures may change due to natural selection. And again, that's going back to that concept of adaptive and non-adaptive traits that we talked about last unit. Okay, for your warm-up today, you guys have this little populations of frogs to look at. So imagine a population of frogs that live in the forest. The frogs have a green coloring on top that helps them blend into the forest. So they are not noticed by predators, so you guys can kind of get this ancestor or this common population. Right here, we have the little froggy with the green forest. Okay, imagine that half of this population stayed in the forest and the other half of the population moved to the hills above the forest, which are drier with some brown grass and brown soil. Okay, so there's our two descendant species. So your question first that you guys need to answer is use your draw tool to circle and answer here. Which population of frogs is likely to have more changes after many generations? So either the descendant species 1, which is the one in the brown hills, okay, descendant species 2, which are the ones that stay in the green forest, or both are equally likely to have changes in their structures. So think about what we just talked about in those key concepts, and then explain the reasoning of the answer you chose here. Okay, if you guys need to, take a second, pause this video, go ahead and finish your Activity 1 notebook and your Activity 2 warm-up, and then we'll move on to Activity 3. All right, so for Activity 3, you guys have a little article to read. I'm going to go ahead and read the introduction to you guys, and then you guys will choose one of the 3 following articles to read about Galapagos tortoises, polar bears, or flightless ducks. So read the introduction to the articles, where do species come from, speciation, and then choose one of the 3 articles to read. Make sure you guys circle your choice so I know what your questions are referring to. So here's your guys' link. The introduction is called Speciation. Okay, so evolution is not just a thing of the past, it's happening all the time. That means new species are still evolving today. There are many ways in which species can evolve, but one type of evolution occurs when one species is divided into more than one population living in different environments. If these populations live in different environments for many, many generations, they may evolve so many differences that they are no longer the same species. What used to be the populations of the same species become populations of different species. The process of one species evolving into 2 or more different species is called speciation. Speciation often starts when populations are separated by a barrier, such as a body of water or a mountain range. After they have separated, the populations don't encounter one or another regularly anymore. They become separate populations, and over time they may evolve into different species. To learn more about some populations that were divided into very different environments and became very different species, choose one of the chapters that follow. So you guys will go ahead and click up here. You guys will choose either Galapagos tortoises, polar bears, or flightless ducks. Again, make sure you guys circle which one you chose, and then you guys will answer these 3 questions. How did the original population that became 2 descendant species first become separated? So basically what happened to that population that kind of forced them into different environments. And then one of the populations had structures that changed over time. Describe the changes that happened and why they happened. So talk about the one that was basically put into a new environment. How did they change over time and what happened to them specifically? Okay, and then finally, why did the other population in the article stay mostly the same or stable? That's the one that stayed in the main environment. So answer that question there. Okay, go ahead, take a second, pause this video, and take care of your activity 3 read and your questions, and then we'll move on to activity 4 sim. Okay, so for activity 4 sim, we're going to be taking a look at a population of australopes. So you guys will recognize this image from our last unit where we looked at the little australope populations in the sim. So an australope common ancestor population is split into 2 different environments. So you guys can see a little bit of information. Environment A had taller thorn palms. Okay, and environment B had thorn palms with larger thorns. Okay, so these are 2 different environments that we're going to divide our australope population into. Okay, so in this sim, obviously you guys working from home will not have a partner to work with, so you guys will need to do 2 parts in order to answer these questions. Those of us in class will be working between pair A and pair B and then sharing information. Okay, so a common ancestor population of australopes was split into 2 different environments, environment A and environment B. Each pair will model one of these environments in natural selection simulation, and you will both compare the descendant species that come from these 2 populations. First, predict whether each australope population will change, and if so, how will it change? So first we're going to start by making a prediction, and then I'll give you guys instructions to actually test this again. You guys at home will be working by yourself, so you guys will have to do the duties of both partner A and partner B, so you guys have something to compare. So reminders, australopes with longer necks can reach and eat taller thorn palms, and australopes with stronger jaws can eat thorn palms with larger thorns. So you guys can kind of predict that those are the changes you're going to see. Okay, pair A, you will model the population of environment A, which changed to have some taller thorn palms. So here's our environment A with the taller thorn palms. And pair B, you will model environment B, which changed to have some thorn palms with larger thorns. So you guys can see those larger thorns in population or environment B. All right, so first thing you guys are going to do is make predictions. Again, you guys at home are going to do both of these. So activity 4, do you think the environment A will remain stable or change over time? So what's going to happen to that population? Circle your answer there. And if you think it will change, what do you think will happen to the australope population? So what change are we going to see in those australopes? Okay, prediction for B, do you think the population environment B will remain stable or change over time? Again, circle your answer there. And then if you think it's going to change, what do you think will happen to the australope population? So what specific change are we going to see in the australopes? Okay, here are your guys' instructions to test this. So once your predictions are done, move on to slides 12 and 13. Here's how you guys test environment A. So follow the directions here. You guys will open the natural selection sim, which again, you guys should be pretty familiar with. And then you guys are going to go up into the upper left-hand corner and open the from 1 species to 2. So if we click right here, we're going to find from 1 species to 2 and load that up. Okay. And then you're going to follow the directions from here. Press rebuild if you or your group mates have made any previous changes. We're just opening it, so it shouldn't have any previous changes made. Okay, press the thorn palm icon and change the most common thorn palm height to 4. So we're going to go ahead, click thorn palms. We're going to change the height to 4. Okay. And then change the thorn palm height variation to medium. So we're going to have medium height variation here. So here's your medium about right here. Okay, so we're going to see a lot of, as far as variation, we're going to see a lot of taller ones, but we're also going to see some smaller ones as well. Okay, and then go ahead and press run and observe the changes. When you guys do that, remember to change your guys' speed to 40, otherwise you guys are going to be here forever. So you guys are watching 50 generations. When you guys are done, you're going to hit analyze, and this is what you guys are going to screenshot, okay? So again, you need to let it run for 50 generations before you guys do that. Go ahead and then pause it at 50, press run, and then you guys will take a screenshot of that and put it on slide 14. Okay, then you guys need to at home test out pair B. So again, you're going to open the sim. You guys will make sure you're in the 1 species to 2, which we're already in right now. So we're going to go ahead and reset this. Okay, we're also going to hit rebuild. Okay, we don't want to have our changes to our population be the same. And you guys are going to run the same thing, except when you guys are messing with the thorn palms, you guys are going to change the thorn palm thorn size. So if you guys look at the thorn palms, you guys are going to go right here to thorn size. Okay, so mess with the thorn size, not the height. Okay, so you're going to change that to 4. You guys are going to set your variation to medium, just like it says right here. And then again, press run, speed it up, watch for 50 generations, pause it, and then you guys will screenshot your analyze histogram. Okay, and then you guys will put that also on 14. So you guys will have 2 histograms at home so you guys can compare. Once you guys have both your histograms to compare, you guys will answer these questions. So with your draw tool, when you and your group mates, so just you and yourself, are finished, compare the neck lengths and jaw strengths of the populations that have lived in environment A and B. Compare the 2 environments where the Australope population was split. Were the environments the same or different? So you guys will circle either the same or different. And then compare the shared structures of the 2 Australope populations. So we're looking at neck and jaw strength. Are the shared structures the same or different? So circle that answer there, and then answer this question. Write a short answer to the investigative question. How does an ancestor population evolve into descendant species with differences in their shared structures? Use evidence from the sim activities to support your answer. Okay, so go ahead and do that, and then we're going to talk about this really quick. So if this were our... So go ahead and finish that up. Take a second. Pause this video if you need to. Finish up the sim, and then we'll kind of wrap it up with our last activity. Okay, just to kind of debrief on the sim, you guys basically had the same common ancestor population of Australopes, and then you guys divided them into 2 different environments. Environment A with the taller thorn palms, and environment B with the larger thorns. Okay, and then from there we formed 2 descendant species. So they have shared structures, but there's a lot of differences in those shared structures. So that's kind of what we're emphasizing here with this image, is we have now 2 descendant species that may or may not ever interact with each other again. Therefore, they're going to keep changing to form different species. Okay, and eventually they'll be so different in their shared structures that they might not even be able to reproduce later in the years if they ever were to come in contact. Okay, all right, moving on to your last activity, which is modeling. Okay, you guys will need the modeling tool open for this, so go ahead, right-click your link and open up the modeling tool, which looks a little bit something like this. Basically, you guys are going to be starting with your common ancestor, and you guys are going to put that common ancestor into 2 different environments, and you guys will get to choose those 2 different environments, and then you guys will kind of dictate what you guys think their shared structures will look like, and how they might be the same or the different. Okay, so let's kind of read through their instructions a little bit better. So your goal is to show how a common ancestor population can become 2 different descendant species when it's separated into 2 different environments. So here's kind of your checklist of what you need to do. Read the information in the lower left corner. So you guys are going to read about different adaptive structures for different environments. Okay. Press indicate environment to choose the environments for species B and C. So you guys are going to choose what species these go into, so indicate what species you guys get to choose. It doesn't matter water, swamp, or land. They just need to be different from each other. So if you choose water up here, then maybe you choose swamp or land for down here. So again, that's up to you guys. Choose your 2 different species. Okay, and then press the 3 structures, species B and C, to show what each structure would be like after many generations. So remember that if you guys are choosing an environment, you guys want to see a longer tail, or excuse me, an environment of water, you would want to see a longer tail. So if we're looking at our common ancestor here, how would our tail different? So you guys would press the thing, and then you guys would choose the longer tail if water is your environment you chose for species B. Okay. Again, you guys can read about the small back limbs, or excuse me, how their back limbs might look. So here's what you guys would choose for that. And then where you guys might see your nostrils. So you guys can choose where your nostrils might be. So here's top, middle, front. Okay. So based on your environment, choose what those structures are going to look like for species B in your different environment and species C in your different environment. Finally, then indicate the organism type. So is this the common ancestor, species A, and then species B and C are those descendant or common. Okay, so fill in all of those. Once you guys are going to have that done, you're going to screenshot that on the next slide, and then finally answer this question if it's going to load for me. So here's your screenshot spot. And then answer this question. Explain how your model helps answer the investigative question. How does an ancestor population, or a common ancestor population, evolve into descendant species with differences in their shared structure? So what kind of has to happen for them to form their descendant species with differences with their shared structures? So answer that here, and then make sure you guys complete your wrap up. Okay, when you guys are done, let your assignment save before you exit out of it and hand it in. You are all done. Again, Let it save and then go ahead and hand this in. I hope you guys are having a great day. Bye.